All right, guys, this is lesson 5.1, solving polynomial equations. So we're going to start with task 1. So let's get started. All right, it says relate zeros and coefficients to polynomial functions. A root is a solution of a polynomial equation f of x equals 0. A zero of the function f of x is any value of x for which f of x equals 0. Thus, the term root is used when referring to an equation, and the term zero is used when referring to a function. The zeros and coefficients of any polynomial function p of x are related in a specific way. Any constant c can be rewritten as cx to the 0 power. For example, the constant 4 can be rewritten as 4x to the 0 power. If you remember from Math 2, anything to the 0 power equals 1. So 4 times 1 is just 4. That's why we can rewrite it like that. So the constant of the polynomial function is also a coefficient of the function. All right, now root and 0 are definitions that you need to know, okay? All right, so let's look down. It says the function f of x equals x plus 4, x plus 1, x minus 1, and x minus 4. So this function is written in factored form. If you wanted to write it in standard form, you would have to multiply those out. And if you look and see, you can have x minus 4 and x plus 4, a difference of squares, and x plus 1 and x minus 1, that's a difference of squares. So this would be very easy to multiply to get into standard form. But factored form is the best way to be able to see the zeros, okay? All right. Now, the first question says, what are the zeros of x? Select all that apply. All right, so I'm going to use the pen here and try to mark the zeros are where it crosses the x-axis. So there's -4, -1, +1, and +4. So there's actually 4 answers here that we need to mark. So -4, -1, -4, -1, and then +1 and +4. All right, so the zeros come from the x-intercepts. And you can see that x plus 4, if you set that equal to 0, equals -4. So this 0 comes from this factor. X plus 1 equals 0, subtract 1, x equals -1, so that factor produces this 0. X minus 1 equals 0, you add 1, so you get plus 1, so this factor goes with this 0. And x minus 4 equals 0, add 4 to both sides, x equals 4. So those factors, when set equal to 0, just like what it says above, okay, when you set it equal to 0, that's going to give you the roots or the zeros of the equation. All right, let's see what the next question says. How does the function f appear when written in standard form? All right, so let's look and see what this would look like in standard form. So like I said, it's given to us in factored form. So we've got f of x equals x plus 4, and you can write the factors. You know, commutative and associative property lets you put these in any order you want. So I'm going to move the -4 over close to the plus 4 just to make it a little quicker. So plus 1, and here's x minus 1. And then to multiply these two, I've got x squared. -4x plus 4x cancel and give me -16. So the middle terms cancel there. And then for this one, same thing. I've got x squared. Minus x and plus x cancel, and I've got -1 on the end. Now I have to multiply these two binomials. X squared times x squared is x to the 4th, minus 1x squared, minus 16x squared, and then plus 16 on the end. So combine like terms. We have x to the 4th, minus 17x squared plus 16. All right, so you can multiply those together, and that puts it in standard form. All right, so how does the function f appear when written in standard form? So that would be this one right here. And then it says, what are the coefficients of f? The coefficients are the terms in front of the variable. So you've got 1, negative 17. And remember, they said you could put x to the 0 power here. So it's 1, negative 17, and 16. All right, it says, how are the zeros of the function f related to standard form of the function? So the zeros are factors of the constant term 16. Remember, 16 is your constant term here. All right, that's all for task 1. We're going to move on to task 2. All right, lesson 5.1, task 2. We are still solving polynomial equations. All right, it says relate zeros and coefficients of polynomial functions. Now consider the polynomial function g of x. What are the zeros of g of x? Select all that apply. All right, so we can look at the graph to determine this, and I do want to look at the graph to determine this. You can see that this is negative 0.5, which means these are negative 0.25 each. So this point here would be negative 0.75. This is negative 0.5, and this is 0.5. All right, so let's see how those relate to the factors. So if we have 4x plus 3, and we set that equal to 0, that's our first factor. Then we subtract 3. 4x equals, forgot my x there, let's see. 4x equals 3, and divide by, my brain's getting ahead of me, sorry. All right, so x equals 3/4. And that's supposed to be subtraction, so that's negative 3/4. So negative 3/4 is equivalent to negative 0.75. So that's that first point here. All right, so the second one, 2x plus 1. 2x plus 1 equals 0. Subtract 1. 2x equals negative 1. Divide by 2. X equals negative 1/2. And you know that that's equal to negative 0.5, which is on the graph here. And then the third one, 2x minus 1 equals 0. Add 1 to both sides. 2x equals 1. Divide by 2. X equals 1/2. And you can see that 1/2 is equal to 0.5. All right, so the zeros come from the factors. When it's in factored form, it's very easy to determine what the zeros are. But let's go ahead and select the zeros that apply. So it says negative 0.75, negative 0.5, and positive 0.5. So those are the zeros of g of x. All right, how does the function g appear when written in standard form? All right, so let's go back to our factors. All right, and so we've got 4x plus 3. We've got 2x plus 1. And we've got 2x minus 1. All right, since I noticed that these are a difference of squares, I'm going to start by multiplying these first. So I'm just going to bring this one down. You can multiply these in any order you want. That's called associative property. I have 3 things, and I'm going to just multiply the second 2 first instead of the first one. So when I do that, I've got 4x squared minus 2x plus 2x cancel, and then minus 1. So again, those are always the easiest to multiply together, so I'll start with them. It's a little quicker. So this one's 16x cubed. 4x times negative 1 is minus 4x plus 12x squared, and then minus 3. So I don't really need my parentheses here. So to write this in standard form, I'm going to have g of x equals 16x cubed plus 12x squared minus 4x minus 3. So this is in standard form. All right, let's go back down to the question. 16x cubed plus 12x squared minus 4x minus 3 is the second answer there. All right, what are the coefficients of g? So we've got 16, 12, negative 4, and negative 3. 16, 12, negative 4, and negative 3. All right, how are the zeros of the function g related to the standard form of the function? All right, so let's see what our choices are. The blank of the zeros are blank of the constant term. All right, so if we go up here and look at well, that was on the screen before when I wrote down what the factors were. When we solved these and I subtracted 3 and divided by 4, so when our zeros were, let me write these down again. So our zeros were negative 3/4, and the next one was negative 1/2, and the third one was positive 1/2. All right, so when it's talking about, I don't know why I'm writing on that. Let me see. All right, sorry about that. Let me click on the pointer here. So the blank of the zeros are what of the constant term? All right, so we got the numerators are negative 3, negative 1, and 1. The denominator is 4, 2, and 2. So we're talking about the constant term. So if we know the constant term is negative 3, then we know that the numerators are factors of the constant term. Because you can see the constant term negative 3, negative 3, negative 1, and 1 are all factors of that. All right, the blank of the zeros are blank of the leading coefficient. All right, so that would be the denominators. The denominators of the zeros are factors of the leading coefficient. So 4, 2, and 2 are all factors of 4, 2, and 2, your leading coefficients there. All right, so that is all for task 2. If you have any questions, please let me know.